Intermediary forms do exist in nature.
At the University of Lund in Sweden, zoologist Dan Erik Nilsson has developed models to show how a primitive eye spot could evolve through intermediate stages to become a complex human-like eye in less than 500,000 years.
Yeah, I've been interested in eye evolution for a long time. And in particular, I've been interested in the question of how long time it would take for an eye to evolve.
Nilsson envisioned a sequence of stages by which a flat patch of light-sensitive cells on an animal's skin could evolve into a camera-type eye. As a first step, nature would favor any changes that made the flat patch more cup-like.
As soon as you've created even the slightest depression in the center, it means that the edges of the cup will actually shade light from parts of the environment. And of course, all the light-sensitive cells in this little cup, they won't measure light in exactly the same direction. So already this cup has some pictorial information.
Another model demonstrates what a primitive cup eye can do. The brightly lighted skulls cast an image onto a translucent screen Nilsson installs at the back of the cup to act like a retina. But the image is not at all well defined. The cup eye can do little more than detect movement. This kind of eye can be found in nature today, in flatworms. Their eyes evolved no further. In their environment, that's all they needed.
But if the animals need to move faster or evolve to become fast predators or to see other fast predators, then the construction needs to be improved. And one way of doing that is to constrict the opening, to make it smaller.
That's just what happened to creatures like the chambered nautilus. Over thousands of generations, natural selection favored those with slightly more constricted eye openings, which focus light more sharply. This worked well, up to a point.
Since this strategy of making a sharp image also has the drawback of creating a very dim image, it's not very popular in the animal kingdom. And there is an alternative solution, which has become very popular in the animal kingdom, the solution that we use in our own eyes, and that is to put in a lens.
Nilsson's model lens uses two thin layers of clear plastic. He can inject water in between them to make the plastic windows bulge out like a convex lens. This mimics what natural selection might have done over a few 100,000 generations, favoring animals with a rounded, transparent layer in their eyes that cause light to be focused more sharply on the retina.
So we can make it gradually from no lens at all and just continue to inject more water, making the lenses bulge more and more, and the image becomes gradually sharper and sharper. So we can go all the way gradually in very small steps from a simple pigment cup eye, which has barely got the ability to determine the direction of a light source, all the way to a complete camera-type eye of the same type as we have ourselves. And that is really exactly the way eye evolution must proceed.
The extreme complexity of the eye left Darwin in a cold sweat, he wrote to a friend. But still, he was convinced that an eye could be formed by natural selection. He later wrote that eyes must have evolved by numerous gradations from an imperfect and simple eye to one perfect and complex, with each grade being useful to its possessor. Nature, unaided by a designer, could produce an organ of seemingly miraculous complexity.